Okay, let us start our discussion on complete mathematical derivation of the asymptote formula. It means that we have to develop a shortcut method. Always it is very difficult to go to these steps, and in order to develop a shortcut method, we have to derive that shortcut method first. In order to derive the shortcut method, the basic principle is same. What the basic principle, I will repeat, I will going to tell again here. Whenever there is a curve f of xy is equal to 0, and this is the curve. In order to find out asymptote for that, we know one thing: as x tends to infinity, whatever the y coordinate in that curve, if it is approaches y mx plus c, or whatever the coordinate will going to become, I can say that becomes the coordinate of the asymptote. Means that as x tends to infinity, the whatever the coordinate on the line of the asymptote will going to points intersect with, means never intersect, they become approximately equal to that one. Means they will going to touch at the infinity. They come to the curve will going to come very close to the, I can say that asymptote in at the infinity. We know that the idea at the infinity, whatever the y coordinate of the asymptote and x coordinate of the asymptote will going to satisfy the equation of the curve. Almost, I'm telling you that almost they will going to equate the that satisfies somewhere. But as x tends to infinity, that's the reason only in the previous classes, as I told you, never get zero. You may get directly after finding the asymptote and if equate it in the equation. We sometimes what happens in the left side is not equal to the right side, but still as x tends to infinity, you can get the there make they equal. That is the understanding point. Now, as x tends to infinity, the coordinate of the asymptote will going to, uh, I can say that, going to satisfy the equation of the x coordinate and y coordinate of the asymptote will going to satisfy the equation of the curve at the infinity. Two things we are going to, that thing we are going to use here means at the infinity means, for if you substitute y equal to mx plus c in this equation and we make the root to the infinity. In order to make the root infinity, what we can do, we can, in order to make the in order to make the infinity root infinity, that we are going to two things. In order to find m and c, we are going to highest degree coefficient of highest, first highest degree and second highest degree equal to 0. And by equating the first highest degree coefficient equal to 0, you can get find out the m value, and second highest degree terms, if you equate to 0 coefficient, I'm telling that, you can get c value. The same idea is here. Therefore, the given equation of the curve can be, we can arrange in the decreasing order of degree. Yeah, first we have to group the into terms like that, terms of degree, and the next terms of degree n minus 1. Then substitute y is equal to mx plus c, and we are going to apply something. Same thing we are doing. What we are doing, I will tell you. What we are doing here, we are going to take this equation of the curve, and we are going the original group of degree n, highest degree n, and then it can be, in that case, if you take x raised to n common, the remaining in the thing in the bracket side, you can get like this. The same thing, y is equal to x by y by x. By putting the same thing, you can get like this. Now, this can be written like this, means a0 y by x raised to n plus a1 y by x raised to n minus 1 can be written as phi n of y by x. How we can rewritten like this, I will prove at the end how this is equal to phi n of y by x. Now, for a meanwhile, you just uh, keep in mind this a0 y by x raised to n plus a1 y by x raised to n minus 1 dot dot an, this is equal to phi n of y by x. This is the first group. Coming to the second group also, the same, that can also be written as, if you take x raised to n minus 1 common, this inside this we can get like this, y by x raised to n minus 1. This can be written as x raised to phi n minus y by x, like that. Therefore, the entire curve becomes like this. The second term like this. Similarly, third group also can be written like that. The entire curve becomes phi n of y x raised to n into phi n of y by x plus x raised to n minus 1 phi n minus y by x, like that we can equal to 0. Now this is what we not done, just some algebraic arrangement we have done, the without changing the value of the equation of the curve. We will not alter the any value of the curve, just make it some simplification, all those things. Now we are going to substitute y is equal to mx plus. Immediate question comes, why we are going to substitute? Because we are going to substitute, the region is at the infinity, the asymptote, the I can say that the point of asymptote will going to satisfy the equation of the curve, whatever the y coordinate and x coordinate. Just by substituting and equate to 0, we can get some x and value become finite. But in our, okay, first we are going to substitute, then we coefficient to 0, the highest degree coefficient and the second highest degree coefficient equal to 0. Then by finding the m and c, we can get the m and c of that asymptote. That reason why we can do here. Here what we can do, just y is equal to mx plus c, substitute in that equation. Whatever this equation for y by, if you put y is equal to mx plus c, this becomes phi n of m plus c by x, and this becomes phi n of m plus c by x, like that it becomes. Now we can apply the theorem. You know that phi of m plus h is equal to phi of m plus h into f dash of m plus h square into f double dash of m 2 factorial. We can already derive this Taylor's theorem in the previous classes. How can we derive it? All those things we know already. If you want to derivation of this Taylor's theorem, you can watch our uh, previous videos. Then you can come to know how this Taylor's theorem expansion is derived. Now for a while, just I written the formula here as it is. Now applying this Taylor's theorem to this one, after applying this one, we can get phi n of m plus c by x is equal to like this: phi n of m plus c by x, phi n dash phi n of dash of m and the first derivatives, and you can say phi n of double dash of n means second derivative of m, like that you can get like this. Then similarly, just and you can, this one can be again by Taylor's expansion, you can write like this and substitute back into the equation, you can get like this: x raised to n, in the place of phi n of m plus c by x, we written like this one. In the place of this one, phi n of m plus c by x, we written this one. Sorry, we written this one, okay, this one. And after we arrange this group, collect means we arrange in the highest degree terms, okay, whatever the coefficient of x raised to n becomes phi n of m, and then coefficient of phi x raised to n minus 1, you can get c into phi n dash of m plus phi n minus 1 m into phi n minus of m, you can get it. Now we are going to equate to 0 in order to get highest infinite roots for x. Under such condition, we are going to find out the m and c. Then we can get asymptote of slope of asymptote and intercept of asymptote. We can get it. Therefore, we are going to equate the highest degree coefficient. The coefficient of highest degree, that is x raised to n coefficient, we can equate to 0, solve for m. And the second degree coefficient x raised to n minus 1 equate to 0, you can get solve for c value. Then whatever the formula, we can get phi n of m is equal to 0, and c we can get like this: cn is equal to minus of phi n minus m divided by phi n minus phi n dash of m, we can get like this. But the question, how can we develop shortcut method? The shortcut method, whenever the given curve is given, we want actually two things. One is phi n of m, and we want another is phi n minus of m. Two things if you know, then it is very easy to find out the m and c here. But how to find out this phi n of m and phi n minus of m? We can find out directly by, if the given curve is there, we can arrange in the I can say that highest degree terms in the decreasing order. Then first, if you take x raised to n and inside the bracket, no, if you, this will directly give phi of a, phi n of m. Whatever this value, we can get it, which is same as if after doing all those process and equating the coefficient, this one means initially we are going to equating, then after applying the Taylor's theorem, then we can arrange them and we can find out phi n of m equal to 0. That value is directly obtained in the initial stage only. Whenever if you take the x raised to n common outside and whatever the inside things, if you in equate to 0, that is equal to phi n of m. The second highest degree coefficient, this phi n minus phi n minus of m, can be obtained similarly in the, if you direct, next one is x raised to n minus 1. No, if you take common and whatever the inside is there, no, if you, this is equal to phi n m 5 n minus of 1 into m. This value obtained 5 n minus of 5 n minus 1 of m. This can be obtained by this quantity. This is directly any the equation of the curve. First thing we have to know what to do, we can arrange the in this degree of decreasing order terms, and taking x raised to n common and equating to 0, can get this whatever this phi n of m, and you can differentiate, you can get phi n dash of m, and directly apply this formula, and you can directly get, once if you phi n of m is there, you could equate to 0, and then you can get slope and c value that can be obtained by this formula. This is how direct shortcut method is developed. But as in the beginning of the this video I told you how this phi n of y by x is equal to this one. This can we now we can prove it. Okay, I want to prove this one. Phi n of y by x is equal to this one. Initially, we know that by using Taylor's theorem, you know that f of x is equal to f of a plus f dash of a into bracket of x minus a. This theorem we know already. I written as it is. I already told you. We want to prove this one, we can watch the previous videos. No problem. Okay. Now coming to this one. If suppose what I want to say, I want to expand around a. This is expansion of the function around a here. But I want to expand the function in the around 0 here. No problem, that is called Maclaurin series. The same thing, phi n of u is equal to like this. Based on this formula you can write like this. In the place of a you can write uh, 0 here, and in the place of, I can say like this, we can get it. Since it is a degree of n here, then it is a become series become finite, because after that phi of n plus 1 is equal to 0. No problem, means all the other terms are not will going to 0, becomes 0. Therefore we can directly written as phi n of u is equal to like this. And this is can be, it is constant here, phi n of 0 divided by n factorial, call this a0, and this one is phi n of what one, this one n minus this preceding previous term is a1 like that, and the last term you can get an like this. If you rearrange it, what we can get, 5 n of u is equal to like this, and again you substitute back u is equal to y by x, then you can get like this. This is how phi n of y by x can be written like this. The same thing as I told you in